Hello everybody and welcome to today's video where we're going to be talking all about shared components, which are a special type of data component inside of Unity's entity component system. Now, shared components basically allow us to do some extra filtering on our entity queries that allow us to filter out by the value of component rather than just the type of component. Now, whether you know it or not, if you've been using Unity's entity component system, you've been using shared data components this whole time. Now, a little bit later in the video, I'm going to be going over what is the exact shared data component it is that you've been using this whole time, and I'll be showing you actually how to use that today. So anyways, shared data components are a useful concept of data-oriented programming because they give us a little bit more control about how our data is laid out, and we can make further optimizations to our game. So this brings up a lot of really good conversations about data-oriented design in general, and these are some of the conversations that I want to start having in some of my videos, basically just kind of around how we can best organize and structure our data in our game to optimize for different individual use cases. Now, every game is going to be unique, and the optimizations that you're going to need to make are going to differ from game to game. So I think that's why it's important to have these kinds of conversations. Now, lately, I've actually been reading the Data-Oriented Design book by Richard Fabian, and I've really been enjoying the book so far. I recommend it. He comes from a game development background, and it kind of just goes over some kind of general principles of data-oriented design. Obviously, this isn't Unity-specific stuff, but as I go through reading this and learning more and more about kind of more general data-oriented design principles, I do want to have some more of these conversations with you all. So do let me know if you are interested in those kinds of things. Anyways, back to the main topic of today's video. We're going to be talking about shared components, basically how they work, when to use them, and then I'm actually going to be showing you how to use them in a little demo that I've made with this kind of like Connect 4 setup that you see playing in the background. And by the way, if you do find today's video helpful and you learned something, I would really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system. Of course, some of these more conversations about data-oriented design in general. And if you do have any questions for me or suggestions for future videos, you can always leave those down in the comments section below, or join us over on Discord over at tmg.dev/discord. So for starters, what is a shared data component? So shared data components are very similar to regular data components in Unity ECS. However, the values, as the name suggests, are actually shared across multiple entities. And the cool thing that we can do with them is we can actually filter out entities by a specific value of component. So this kind of leads to another way about thinking about how we actually structure our data. And I'll be talking a little bit about more about some of the considerations that we might want to make when we're using a shared data component. This also leads to more efficient processing because, for example, we can filter out things by a specific shared data component and only process on things that fit that certain criteria of having that shared data component. I kind of mentioned that, this whole time you've been using shared data components without even knowing it. So the shared data component that you've actually been using is the mesh renderer. So in Unity ECS, basically the mesh renderer is a shared data component. And the advantage of this is it can basically process things in batches. So if it knows that a bunch of entities all have, basically like the same material color, they're all receiving shadows, it can process those basically in sequence. And because they have all these shared properties, it's a lot easier for the computer to, process things of this same type when it comes to rendering, as opposed to, going through each and every single entity and then seeing like, oh, okay, does this one need shadows? Does this one cast shadows? What's the color I'm supposed to be rendering? It's just kind of a lot of work for the computer to, go back and forth through all these different things. And it is much more efficient for the computer to basically just say, render everything with these specific values, and then we'll move on to the next set of things with its own different set of values. All right, so let's go a little level deeper and talk about kind of how these shared components work. So real quickly, I'm just going to go over the concept of an archetype if you're not already familiar with it. An archetype is basically just like, you can think of it as kind of like the structure of an entity. So if an entity has, a maximum health component, a position component, and a speed component. So the archetype is basically just kind of like the definition of the overall structure. The archetype doesn't necessarily contain any entity data. What does contain entity data is something known as a chunk. Now, each archetype is going to have, a different chunk associated with it. And these chunks basically get filled up with entities and their associated data. And these chunks are basically just blocks of memory that this entity data lives, so that when we do an entity query, we can just basically pull in that chunk of data, and that's how we can do that super fast, efficient processing on it. So the reason I bring up chunks is because each chunk is just going to have a pointer to the shared component. So the shared component is, shared across many of these entities. So, there's not, not each of these entities has to worry about holding the actual data of a shared component. So we can kind of cut down on memory costs if we know that, a bunch of things are going to have the same maximum health. We can use a shared component to basically store all that data for all the entities in that chunk in just one single location, and then every entity can just basically point to that. So again, there's no memory cost on a per entity basis. It's only on a per chunk basis that we have to worry about. Now, one thing with shared components that confused me a little bit at first was actually modifying the data. So when you modify the shared component of a specific entity, it doesn't change the data for all other entities with that shared component. In fact, it actually just changes the data for that one single entity. Now, what happens when you're doing this is because, that entity no longer points to that shared component value that it was in before. It actually has to create a new shared component with a new value and then associate it with that entity. Now that entity actually has to get moved to another chunk now because it doesn't fit that criteria of having the specific value for shared component. Now you do need to be careful when you're modifying these shared components because that is considered a structural change and it will generate a sync point in your code. So the last thing that I wanted to go over before we get into the tutorial section of this video is when actually to use shared components. When is the time that it makes the most sense to? So the ideal case is when you have, of course, data that's shared across many entities. It doesn't make sense to have, extra data on a per entity basis when that value is basically just going to be the same. It's also important that this data changes very infrequently. Like I mentioned, when you change the data, it incurs a sync point, and that's just kind of like a bottleneck for your code. So you want to make sure that you're only really using these shared components on things that aren't changing very frequently. Another use case is when you want to further filter down on entities based on a value when just adding a component to them doesn't necessarily make sense. And again, just a couple words of caution, just make sure you're not overusing these shared components, because if you overuse them and you get to the point where you have many different values on these shared components, it's really going to lead to poor chunk utilization. So maybe you have like a bunch of chunks allocated, but you only have like 2 or 3 entities in each of these chunks. Then that's just kind of like a bunch of wasted space of memory now. All right, so here we are over in Unity, and now I'm going to be using this simple little Connect 4 game to show you how to use shared components. By the way, all the project files and code featured in this video are going to be available using the links in the description below. Anyways, so the idea of this game is you have the numbers 1 through 7 down across the bottom, and when you press a number key, say the number 1, it's going to go ahead and drop a piece down there. Same thing if we did, 4, 5, 6, it's just going to go ahead and drop a piece there. So now, of course, with the game of Connect 4, the idea is that you kind of like take a piece in and you drop it down from the top and it falls down to the bottom, and it's going to stack upon all the pieces below it. So the first kind of problem that we have to come across is what happens when, say, we drop a piece down in row 4. How do we actually calculate that it needs to go above this piece here? And then, when we start stacking these up, how does it know basically how far down we need to drop the next piece in the sequence? One easy way that we could accomplish this in Unity ECS is basically just going through all the pieces in our scene and then determining what is the highest position in this specific column that we're trying to spawn a new piece in. So of course we can just use a variable called highest position to track the value. We'll start this off at a value of -1. So we'll just do an entities.forEach on everything with a position component. So that's basically just everything with a grid position on our board. So we'll just check if the position.x is equal to the spawn column, meaning this is a piece in the column that we're trying to spawn a new piece in, and if the position.y is greater than the highest position that we've already recorded. If it is, then we'll just set the highest position equal to the current Y position of the piece that we're checking. Now you can probably already see a little bit of an inefficiency with this because we're checking every single entity, and we're going to be ignoring a bunch of them if the position.x is not equal to the spawn column. So, maybe we have like 20 of these pieces in our scene, but for whatever reason, there's no entities in the column that we're actually caring about. Then we actually have to go through all the entities in the scene, no matter what column they're in, and then basically just ignore it and then move on to the next and the next until we find something in our column. And then we can say, okay, if the Y position is greater than the highest position already, we can set that highest position here. So even though this is like a really simple example, and obviously the computer can, iterate through 20 entities, no problem. I mean, you can see how this scales to, much bigger projects. Now, a much better solution would be to use a shared data component for the horizontal position. This basically means we can group together everything in a single column, and in that way we can just filter across all the entities in that single column, and then we can determine the highest position much quicker than going through all the entities in all the columns. So here's the actual shared data component. You'll see that it's set up very similar to a regular data component. Of course, we're just doing a public struct, and I've named this horizontal position, and then it implements the iSharedComponent data interface rather than just the iComponent data interface as normal. And then you'll see I just have a public integer called value. So really easy setup. And one thing to note about the shared components is we actually cannot use the generate authoring tag. So we can't, assign these shared components to entities in the inspector as we would like to. We do have to add these shared components to entities through code. So now you'll see here in my onUpdate function, basically the first thing that I'm just going to do is determine what is the actual column that we're going to spawn into. And then I kind of have this just like player input. Basically, if you press the 1 key, we're going to spawn in column 0, which is the furthest to the left. Press the 2 key, spawn in column 1, and so down the line all the way up to 7. But I've just used this region to kind of hide things away. So if spawn column is equal to -1, that means that the user basically didn't press anything. We're just going to return out of the function. However, if the user did press something, we're going to create a new horizontal position, which again is that shared data component of type horizontal position, and we'll just set the value equal to the column that we want to spawn in. So we're actually going to be using this data component here for a couple things. We're going to be using it to filter against all the existing entities, and then later we're going to be adding this shared component data to our new piece that we're spawning in our world. So you see here, very similar as before, we have a value to track the highest position. And then this time in our entities.forEach function, you'll see that there is a different one, a different little step that I've added here, which is the .WithSharedComponent filter. So this basically allows us to filter against different types of these shared data components. And then here we pass in the new horizontal position, which again is just that data component that I created right up here. So basically this is how we can, filter against anything that not only has a horizontal position component on it, but has a specific value of horizontal position, which again is the value that we defined up here for the spawn column. Then from there, we can just do a .forEach, and then we're still going to need a reference to the vertical position. The vertical position is not set up as a shared component. We'll be talking a little bit about that later, but basically we're just going to check if the vertical position's value is greater than the existing highest component or highest position. If it is, the highest position is now equal to the vertical position.value. So again, that's how we can basically just filter across all entities in a specific column and then process them extremely quickly. So then we just check if the highest position is greater than 5. If it is, we'll just return. That basically just means that that column is filled up and we can't add any more pieces on it. Now here I have just instantiating a new piece here. And then here is where we actually add the shared data component. You'll see we can just use the entity manager and just do an add shared data component, passing in the new piece entity, as well as that same new horizontal position shared data component. And then here we can just create a new vertical position component equal to the highest position plus 1. We'll go ahead and add that component data. We'll actually set the translation component to the XY here, and then set the component data. So basically, if we head back over to Unity here, Now when I press, say, the number 4 key, the new piece spawns right on top of here. And then, we can continue this all the way up the column, and then, same thing in any of these columns here, and we can just go ahead and fill up the entire board, because why not? Now the next portion we're going to go over is how we actually set the color of these entities. Like I mentioned, the RenderMesh component is a shared data component, and we want our game to be a little bit more interesting than just having only white pieces. We want some blue and red pieces, so we can actually play against our friend and actually kind of have some fun here. So jumping back over to the code, we can basically just check our spawn data, see if it is the red turn. And then I've created this little function here called set piece color, where we're just passing the new piece entity as well as the red material off this material data component that I've created. All right, and then so here is the set piece color function. So basically we're just setting up this RenderMesh variable, and to actually get the shared component, we're going to do an entity manager.get shared component data. This is a specific one for shared components. And then we're just going to use the type of RenderMesh. And again, we're going to be doing that on the new piece entity. Now, the reason we actually want to get the shared component first is because, these RenderMeshes have kind of a couple steps to set up to actually use them. So it's best for us to actually just get a reference to the current one. We'll go ahead and make any necessary changes that we need to, and then we can go ahead and apply those changes back to the entity. So we'll just go ahead and do a RenderMesh.material, and we'll set this equal to the piece material. So this basically assigns it the color of blue or red. Now we just need to go ahead and apply that change back to the entity. So we'll just do an entity manager.set shared component data, passing in the entity as well as the RenderMesh. Now coming back over to Unity over here, you'll see that when I press the number 1 key, we'll get a red dot, and then go ahead and press the number 1 key again, and now we'll get a blue dot, and it's just going to alternate back and forth between red and blue. So now we have kind of all these alternating colors here. Now, even though these red and blue components are all have the same shared component data, they're actually going to be set up in 2 separate chunks, again, because they actually have 2 shared data components, one for the horizontal position, and then another one for the actual material data. So because we have 2 different colors of entities, these are going to be set up in 2 different chunks in our game. Now, of course, because this is a Connect 4 game, we actually want to be able to have some sort of win condition. And so basically the only solution that I've implemented for this simple little demonstration is just the vertical solution. So basically if you have 4 pieces stacked vertically, that's the only way you can win in this game. And I'm going to be showing you kind of like an optimization that I made with shared components to optimize for that vertical solution. So that's kind of why I only have this implemented right now. So you'll see if we just kind of alternate back and forth, we have 3 reds in a row, and I go ahead and press the 1 key again. Now we have 4 reds in a row, and they turn to these yellows because those basically signal it being the winner. So basically after we set the piece color, depending on, if it's the red turn or not, then we'll actually go ahead and check for the win condition. To do that, we'll just go ahead and actually pass in the new horizontal position, again, so we can filter out against everything only in that single column, because we only, if we're spawning a new piece in that column, we don't need to check all the other columns for win conditions. Now, if we were optimizing for a different type of solution, maybe the horizontal or diagonal one, maybe we'd actually have to think about how we restructure this. And then the other thing that I'm doing is I'm just passing in basically this enum reference to this connect4color.red. All right, so here's the actual check for win function here. Now we have to do something a little bit interesting, because the way that the entity component system works, basically when we want to filter across a set of entities, we can't necessarily guarantee the order that they're going to be in. As shared components change, and maybe we're adding and removing components from entities, that's going to rearrange the order that these entities show up in memory. So we can't necessarily always rely on, the entities being in the sequential order. And so, of course, with the game like Connect 4, we need to check for a specific order to see if 4 of these pieces are exactly in a row. So the way that we kind of have to do this is I've set up a native array here of this connect 4 color enum. You can see the connect 4 color enum. Basically, we just have 3 options: none, red, or blue. And again, I'm just using a native array here just because I think it's good to get in the habit of using these when we're working with the entity component system. However, we can just use a normal array here. It would work perfectly fine for this particular situation. And then, so basically the first thing that we're going to do is we're going to check through all the entities that again have that shared component of the specific column filter. Again, we're only checking the win condition in one specific column because, when we put a piece in, we just need to check for a win condition in that specific column. Now, it would be a little bit different if we were also checking for, the horizontal or diagonal win conditions. But for the vertical win condition, we can basically just filter off everything that's in that single column. Now, the idea here is that we're going through every single piece and we're going to be checking the material of the render mesh of every single piece. And we're going to see if it's a red piece or a blue piece, or if for some reason it's neither. Now, you may be thinking, hey, maybe we can add in another shared component filter for something with the render mesh because the render mesh is a shared component. So maybe we can filter against that as well as the column filter. Now, in theory, that does make sense. And that's something that I actually tried to do at the beginning. However, the entities.forEach function only allows you to filter against one shared component at a time. Now, you can actually create an entity query and filter against up to 2 shared components at a time. And then that way you could actually go through the entity query and then check against things that way. But anyways, you'll see that what we're doing is basically we're just setting the piece active, which is this native array that I set up, at the position of y.value. So we're looking at the vertical component. So we're basically, ordering these from 0 to 5 based off of the vertical component. And then we're basically just setting whether it's a red piece, a blue piece, or neither. Now you'll see that I am using an in reference to the render mesh. And because we're doing this, we actually have to run this for each function without burst and run it on the main thread. That is a limitation of shared components at this time. And then here's where we kind of check for the winning condition. Basically, we just need to see if there are 4 pieces in a row where the value of that is set to current turn. So, current turn, if it's the red turn, then it's going to be the red value of the enum. If it's the blue turn, it's going to be the blue value of the enum. So again, this just checks for a winning condition for 4 pieces that are all aligned vertically in a row here. This basically just means we do not have the win condition met, so it's just going to return out of here. And then finally, the last thing that I do want to show off that does actually relate to the shared components again is we're going to do another entities.forEach function here. Again, we're going to be filtering off of everything with the column filter here. And then we're going to do another thing for with structural changes. Now we do have to include the .with structural changes because in this case, we're going to be modifying the render mesh component. You'll see that we do not have the ref or in keyword before that. And that's basically how we can modify the render mesh component for a specific entity. And then inside here, this basically just sets the material to the yellow material for any pieces that are essentially involved in that win condition. Now, the way we do that is we just do an entity manager.set shared component data, much like we did a little bit earlier. And again, we do need to run this without burst on the main thread. And so that is essentially how, if we're playing, a Connect 4 game, it doesn't matter, how that vertical win condition is satisfied. But when it is, then it's going to go ahead and turn all the pieces for that win condition being satisfied to yellow. Same thing with the blue pieces. If we wanted the blue pieces to win, it's going to go ahead and turn those all to yellow pieces. But anyways, that's kind of an overview about shared data components. I know this video was a little bit longer, but these are really important to understand and learn. And there's a lot of really cool things that we can do with them. And again, this brings up a lot of interesting conversations about how we can organize and structure our data in our game made with a data-oriented design in mind. And so just a quick example of that before we wrap up is you'll see that here we do have the horizontal win condition met, where we do have these 4 red pieces sitting in a row here. Now you might be thinking, oh, let me just use some shared components again, and then we can use, have the vertical position be a shared component. We can just, filter off everything in a particular row instead of a particular column. However, that starts, kind of fragmenting our data a little bit more, because now we have a vertical shared component as well as a horizontal shared component. Now, this basically means that for every unique spot on the board, if an entity lives there, it's going to live in a different chunk of memory. So that pretty much negates any of the, optimizations that we would have had by using shared components in the first place, because the entities are all basically just being split up into different parts of memory anyways, and then that's literally no better than any type of object-oriented programming solution. So the data-oriented way of actually figuring this out is we can actually duplicate the data. So we can have the data live in multiple places, and then we just need to make sure that we're keeping that data kind of in sync. So that way that, we can have the best of both worlds, where we can filter across the vertical solutions if we wanted to, and then we could have a second set of data that actually is filtered out using the vertical position as the shared component instead of the horizontal position, and then that way we can check for the horizontal win condition. Now I know I'm kind of going on a little bit of a tangent, and again, these are some of the conversations that I would like to have in more videos later on, but the key thing to keep in mind is you always need to optimize for the most likely scenario. So what is the win condition that's most likely going to happen? Go ahead and optimize for that, and then you can worry about the other cases later, because those are not going to be happening as frequently. Anyways, that's going to go ahead and wrap up today's video about shared components. I do hope you enjoyed it and you learned something. I know I had fun making this project, and it does inspire me to kind of learn more about data-oriented design and some of the kind of unique things that you can do and think about when you're utilizing it. So once again, if you did enjoy today's video and you learned something, I would really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system, their data-oriented technology stack, and hey, maybe even some topics on data-oriented design in general. Of course, if you do have any questions for me or suggestions for future videos, feel free to leave those down in the comments section below, or join us over on Discord over at tmg.dev/discord. I'll see you there.